call a number, right? Call a number A. As long as this number is in between of x and the 3x squared, we're fine, right?
Right. So this would just be A.
Yeah, just let a number be somewhere in the interval of x and 3x squared, right? That seems to be A, to be safe, right? But if we choose 0, we limited ourselves. Okay, now, second question. So why do we have to do this? Why do we have to split this integral into two integrals?
Because both the upper and the lower have an x, and the lower limit should be a number.
Okay, what's the purpose? We want to make the lower limit to be a number.
To have a definite integral, I believe.
Well, we won't be able to have definite integral, right? Because we have x. We have x as a limit. There's nothing to do with the definite integral. But what do we want to apply here? So what is the purpose we're doing this? You split the one integral into two integral. You want to use a theorem, right?
Right.
What is the theorem?
I had forgotten. Oh, is it the fundamental theorem of calculus?
With a question mark, or are you?
That's my.
Right? See the statement.
Yeah.
You want to apply the fundamental theorem of calculus. That's why you split into two integrals. That's why you want to find a constant in between x and 3x squared. So you split into two. As you said, you want the lower limit to be a constant. All right. Okay. Now explain to us the third step.
This is supposed to be.
For the rest of you, please do not read what you have on the paper, because I have two eyes. I can see what you read, what you write on your paper. I need you to explain. Presentation means you explain the concept behind it. It's not read what you have on the paper. I can read myself, right? So this is to show you understand. This to show, even somebody did the work for you, but you know what's going on. You understand. Does it make sense? I hope this makes sense. So please get yourself ready not to read your work, to explain your work. All right. So we don't really have time to spend time like this. Okay. Anyway, keep going.
I had switched this interval so that x would be on top.
You mean you switch the limits of the integral?
Yeah, I'm sorry.
So when you switch the integral, what happens? When you switch the limits of the integral, what happens?
I'm not sure what you mean.
Right, you have this negative sign, right? What does this negative sign come from?
From switching the limits.
Right, when you switch the limits of the integral, that introduces a negative sign.
Right.
Okay. Now, can you explain to us from this one to the next step, what happens? What happened?
Oh, so to find the antiderivative of sine of 7 minus 4t, I used the u method.
Oh, hold on a second. You're missing something here. Why you change d dx to d du?
Oh.
I think this
Oh.
is, you mean dx, right?
Yeah, oh my gosh, yeah, 'cause I was writing that while I was writing the U method here.
Yeah, you're missing some steps here. Okay. So you want to, I'm not quite sure what you want to, no, you skip some important steps. Okay, so you read dx, now everything's right. Right, dx. But how do you do the u substitution? You wrote up there, you said, okay, let u be 7 minus 4t, d du.
So,
No, your u is a 7 minus 4t, right?
right,
What
and
would
the
you
derivative,
do sign? Oh, I see.
-4, we divided by -4, and then the derivative of sine of u was, oh wait,
We lost you, Alexandra.
oh, sorry. So then, I found the derivative of sine of u, and then that would have been cosine of u, but then I had just negative cosine of u, the antiderivative, and then I had just added the -1/4 to it, which would have canceled the negative sign, and that would have been over 4.
Okay, that's fine. That's fine. But how did you go from this step to the next one? You're missing one step.
Substitution of 7 minus 4t for u.
Right, because we don't see du, right? We don't see du. You're missing one very important step to do the substitution, to show with the substitution.
Would I have to put du next to?
You have to put it like, I think you intended to do it. So d du, let's write here. Let's erase this. So you need to add, this of course is x. Right, this is x. You want to write an equal sign here. Because you have to show the very important step to change to be substitution. So I think you intend to do d du. Well, let's put the negative sign up front. Then you want to integrate from 0 to x, right? Then you have this sign of the sine term. I'm not going to write the term. Okay, sine term dt. Then you have du dx. You probably meant to write this.
Right.
d du times du dx is still your d dx, right?
Right.
Right. So you want to apply your u method. Then you can change this inside to be sine 7 minus 4x to be sine u.
Mm-hmm.
Right. Then dt, what do you switch the dt?
dt will be substituted with -1/4 du.
Good job. Right here. Yeah. It change to be this. Then you can apply the fundamental theorem of calculus. Okay? The fundamental calculus will give you this. Give you this part from fundamental calculus. Then the 1 is d. What do you have? You have du dx somewhere. Right, you said already. Du dx is 1, right? So you have 1 here. All right, can you try to explain the second part, this part?
Okay.
As what I did? Yeah.
Right. So you find the antiderivative again of sine 7 minus 4t, which we already know is cosine of u over 4, and we know that u
No,
is...
this is just, okay, hold on a second. Don't put a 4 here, right? That's confusing. You already have a -1/4 here. This has no 4, right? du sine u just cosine u. There's no 4. Do you see that? Because
Oh, okay.
u is your variable. U is your variable. There's no 4. You don't have 4u inside the angle. So this 4 is, right. I think you get confused. You see this divided by 4 is showing up here, right?
Mm-hmm.
U dt has this, involves this over 4. You want to write, you want to try to write this one here?
Yeah, sure, I'll try.
Just as, you know, what I read here.
So, okay, so sine of u of dt, that would equal cosine of 7 minus 4 times 3x squared
Right,
over, or I could say over 4.
right. That's because you change your dt to be -1 over, no, your dt, what's your dt? You need to solve your dt. Right now your u is different, right?
Right, dt would be -1/4.
Right, you need to find the
And
dt over the dt dv.
dt, what did you say? dt.
Oh no, you're still right. You're still -1/4. Right, right here.
Yeah,
Right here. Right, because your
okay.
u equals 7 minus 4t, right? Your dt is still equal to -1/4 du. dv, right? du.
du over, then du over dx would be 6x, right? The derivative of 3x squared.
Exactly, right. du dx would be 6x, right?
And then we simplify it, which I've gotten afterwards.
Right. Do you see now your answer makes sense? But this, okay, this is a typo, I think. This is plus or minus? Oh, negative cosine, right? Negative,
I
become positive. Right, that's positive. You're right, that's positive. Because you have negative quarter,
I just,
right? A sine, derivative of sine is negative cosine, negative, positive. So try not to skip important steps. So this is the important step, right? Without this step, you won't be able to apply the fundamental theorem, right?
alright, I'll do that next time.
Okay. All right. Thank you, Alexandra. All right. Anybody has any questions? Okay, let's go next one. Thank you, Alexandra. Let's see. Next one is Carlos.
Yeah. I don't know. Can you see it now?
Yeah.
Okay. So the question is to find the first derivative of each function. Okay. So what I did was I rewrote the square root, whatever we have it here. Rewrote it as 9 is 5x to the second power, parentheses 1.5. And to regard of that, we know that 2 it's a constant, so we just put it aside. And then we know that we have to use the product rule. So on the side I left f equal x if the derivative is equals to 1. Keep it the same way it was here, and then we find g prime. But in order to find g prime, we have to use the chain rule. I wrote it here. After, well, and this is 1.5 minus 1, so that's why it's negative 1.5. And then we take 1.5 to the outside, and we have our function to find the g prime. Sorry, just my computer's kind of stuck. Okay, and then we have for g prime we have negative 5x over parentheses minus 5x squared 1.5 for the square root, so on. And then we apply the product rule. We replace our variables f1. So here f1 prime. We get g, our g, and then we get our f, and then g prime. Okay, and then we just implement it and leave it to outside. Of course, 1 will give us the same result. And we distribute x to this. And we get negative 2 parentheses 10x to the second power minus 9 over 9 minus 5x squared 1.5. So I'm sorry, I'm not sure you can hear me. It says I have a low connection.
Yeah, I can hear you, but sometimes a little bit on and off, but you're okay.
Okay, so g prime, this is our answer for g prime. Actually, not g prime, but this is our answer. Minus 20x to the second power. We distribute the negative 2, and then we get minus 20x to the second power plus 18. And you can either leave this question like this. I don't know if you can leave it like that. Or you can also, instead of this, can also become
Rather than
that will be our
term. Okay. Yeah, go ahead.
okay, so this will be our answer. So plus 18. I don't know if it's not writing anymore. Sorry.
Let me write for you, plus 18. Right, if you leave like an expression raised by half, that's considered as not simplified. So this is a better answer. This is a better one. But I was about to, right, you find yourself confusing, so cross this g prime, right? But let's figure out this. So your function is given as g of x. You want to use product rule. Let's call this h instead of g. Right? You have f times g. Does that make sense? F times h. So g of x equals to f of x times h of x. Just use another character, right?
Mm-hmm.
So you call this h prime. So this is h prime. Then you can call this g prime, right? Because this is your g prime. Because your function is g.
Yes. Oh,
Make sense?
yeah, it makes sense. Yeah, I was.
You don't have to use the same character, right? You just use another character. Use H or use K.
Oh,
Okay.
okay.
Right. This is
Okay.
good. Right? You explain that you are using product rule. Right. Okay, great.
Yeah.
All right. Thank you, Carlos.
Thank you.
Okay, next one. Sophia, I think is the next one. Sophia, are you ready? Okay, Andrew, are you ready? 23. Okay, Amir, are you ready? 40.
Gotcha.
Oh,
Hello?
hello, yes.
Oh, yes,
Oh,
I'm
Andrew.
ready.
Okay, go ahead.
I'm just sharing it now.
Okay.
Are you able to see it?
Yeah.
Okay, great. So for this question, we are asked to evaluate the integral. I used U substitution to solve this question. So first, I let U equals cosine 2x, and then du over dx, which is derivative of U, using the chain rule, which I did in the right, and found that to be -2 sine 2x. And then since we have sine 2x dx in the integrand, we can substitute it into, we can find that using, by rearranging the equation, du over dx equals 2 sine 2x, -2 sine 2x. I just cross multiplied and divided by -2 and found sine 2x dx equals to -1/2 du. And then in the third step, I just I just rearranged the terms to get sine 2x and dx together. And then in the third step, below that, I substituted u for cosine 2x and -1/2 du for sine 2x dx. And then let me try to estimate here. Oh, this. I took out -1/2 since it is a constant, and then found the antiderivative of e to the fifth power using the power rule for integration. And then we add the c since it is an indefinite integral. And then in this step, I took out 1/6 and multiply the 2 and found -1/2. And in this step, I just substituted cosine 2x back into u to the sixth power, and then this is the final answer I got: negative cosine 6 to the sixth power, negative cosine 2x to the sixth power over 12 plus c.
Yeah, that's it. Okay. Very nice. So what did you write on the corner? What's this?
This one, this?
This in the corner, on the top corner,
Oh yeah,
cosine.
I use chain rule to find the derivative of cosine 2x. Mm-hmm.
Oh, all right. That's just your calculation.
Yeah.
All right. Okay. So this is Andrew. All right. Thank you, Andrew. If
Thank
anyone
you.
has any question, feel free to jump in. All right. Sophia, you have internet problem. That's okay. You know, whenever you're ready, all right? Don't, right. So we can wait for you. No worry. So next one. So Alexandra, Carlos, Angel, Amir 40.
Oh, yes, Professor, I'm ready.
Okay.
So for number 40, we're told that if 1,200 square centimeters of material is available to make a box with a square base and an open top, find the largest possible volume of the box. So what I first did was I like to visualize it. So I actually drew the box. So if we were to just draw it quickly. Um, Alright, that's supposed to be a cube. Sorry, my drawing's not that great. Anyways, so what I did was I set our lengths equal to x. So this is our square base right over here, and then our width, our height can be y. So our length and width are x, and our height is y. So then there, all we have to do is well, we know that the surface area is 1200 because that's the total thing. So what we'll do is this: the surface area of the square, the area of this square over here, the square base, that'll just be x squared. And then we're given 4 sides with an open top, so this we disregard. So we have your xy 4 times, so that's 4xy. This is the surface area. 4xy, the sum of the areas. 4xy plus x squared, and that's equal to 1,200. And then also what we're given, we know that the volume of a box is always length times width times height. Our length is x, our width is x, and our height is y. So our volume can equal x times x, that's x squared, and then y. Now what we're asked to do here is find the largest possible volume. So what we need to do first is get one variable in terms of the other. So what I did here was I solved for y over here on the top. That's easier. So first you subtract x squared, and we get 4xy equals 1200 minus x squared divided by 4x. You get y is equal to 1200 minus x squared. Yes, this should be a 4x right here. Over 4x. We can further simplify this if we separate into 2 fractions. We have your 1200 over 4x, or just 300 over x. And then we have your negative x squared over 4x. Or what we can simplify that to is negative x over 4. So this right over here is our y. So now we go back to this volume formula, and then we substitute. So then v equals x squared y. our y is 300 over x minus x over 4. And all we would do from here is we would set it equal to 0 to find the maximum volume. So from here, what we would have is yeah, all right. You have your 300. Wait, it's actually before that we need to differentiate. Forgot about that. So v prime, that would be equal to 300 minus 3x squared over 4. So if we were to, first of all, we can obviously what do you call it? We can obviously multiply to make this simpler right over here. So 300x minus x cubed over 4. And then we take the derivative. So our derivative would be 300 minus 3x squared over 4. And that's equal to 0 because we want to maximize. Then all we would do is solve this. So if we were to add 3x squared over 4 to both sides, 3x squared over 4 equals 300. X squared equals 1200. X squared equals 400, and because we're solving for length, it's a positive value in this case. So our x now we know is 200.
You mean 20?
I mean 20, yeah, sorry. And then from here, all we would do is evaluate v of 20. So you have your 20, and then we would have here your volume. That's if you know, we would evaluate our what do you call it, our v 300x minus x cubed over 4. That's our original volume. And all we do is just plug in x. So we have here 300 times 20 minus 20 cubed over 4. And that right here would equal 4,000 cubic centimeters.
Okay, great. So I would just cross out this. This not equal to 0. This v right here. You meant the derivative.
Yeah, that's what I meant.
Right. Okay. Anyone has any questions? This is a what do you call it? Maximization, right? Minimization, maximization problem. Okay, great. Thank you, Amir.
Thank you.
Okay, Amir. Sophia, whenever you get ready, you can go. All right. Read 19, then Kaiser 45. You read with your paper 19.
Yeah, hello, Professor. Yeah, okay. So the question is asking a rectangular or storage container with an open top is to hold 100 centimeter cube. The length of the base is 3 times the weight. Material for the base costs $12 per centimeter square, and for the side costs $9 per square. Find the cost of the material for the cheapest such container. So we are given the volume is length times width times height, which is equal to 100 centimeter cube, and 3W equals L because length is 3 times of the width. So if I substitute 3W for L, we got 3W times W times height equals 100 centimeter cube. And if we solve for H, we got 100 over 3W squared. So then we find the cost of the base. The base is $12 times the length and the width. So I do the same. So length times width equals 3W squared, and we got 36W squared. And the cost of size is $9 times 2 length times height plus 2W times height. And the result we got 2,400 over W. So if we want to minimize the cost, we have to derivative. So I derivative 36W squared plus 24 over W. I mean 2,400 over W, set it equal to 0. And the result for W, I got $3.22, and I substitute $3.22 into the equation, and I got $1,118.06.
Okay, I think so this is your cost of function. Cost of function, you could write it as cost of W, because this cost function is just in terms of W now, equal to 36 W squared plus
2,400 over W.
Over W, right? So you need to write this together because you separate into 2 parts.
Okay.
Divided by W. Then, as you said, you take a derivative of it. So you have C prime. You set C prime equals to 0. You solve for W. All right. Okay, great. All right. Anybody has any questions? This involves the money, right? That's why we need to form a cost of function. It's not only maximize more volume. So this we want to minimize the cost. So that's why Ray has to figure out the cost of the base and cost of the size. Then add them together, make a cost of function. If we want to minimize, then we take a derivative of the function, we set to 0. All right, anybody has any questions? Okay, good job, Ray. Thank you.
All right, thank you.
Okay, I think, what's next? Yeah, Sophia, whenever your internet works, you can go. I think it's Kaiser, right? Kaiser wants to show.
I'm gonna do 7 because I did it somewhere else, number 45. It's not on the device that I'm on right now.
Oh, okay.
Okay, so for number 7 we had limit of x to 0, x squared sine 1x. So I first substituted in 0 to try and evaluate the function, but I got d and e. So I split the limit into two parts. Limit x to 0 of x squared and limit x to 0 sine 1x. We can use squeeze theorem to solve this problem because we don't know what sine of 1x is. So we know that sine is between -1 and 1, so that function is going to be between those values. We can use x squared as a function greater than sine 1x, so we can use that, and a function less than sine of 1x is negative x squared, so we can evaluate both of those approaching 0, and we get 0, and since the limit approaching 0 from the right and left is both greater than and less is both 0, then the limit of x approaches 0 of x squared sine 1x equals 0 because it's between 0 and 0.
Great. Great. Good job. Anybody has any questions? Yeah. Good job, Kaiser. Thank you. Okay, I see this. What this question? Oh, someone's work just gone, just disappeared. Kaiser, so Zuli 38. Now I see. Let me see.
Can everyone see?
Yeah, I can see it. 38, right?
Okay. Yes. So the problem we're giving is a rectangular storage container with an open top holds 10 centimeters cubed. The length of the base is twice the width. Material for the base costs $15 per centimeter squared, and for the sides cost $8 per centimeter squared. Find the cost of the material for the cheapest such container. And so we are told, sorry, I got distracted by the chat. So with that, we have to write out the known information. And so we know that the volume is equal to the length times width times the height. And so the length is twice the width since the volume is equal to 10, we find the height in terms of width. And so we get the height equals to 10 over 2w squared. And now we have to find the cost. So the cost is 10 times the area of the base, as you see there, and then plus 8 times the total area of the sides. And so then we fill out the length, we fill out the height and length in terms of width from above. So we could find an expression for the cost in terms of width only. And so after we do that, we get CW equals 20W squared plus 240 over W. And so to find the minimum value, we start by differentiating. And so we do C prime of W, which equals 40W minus 240 over W squared. And then we find the critical values where C prime is 0 or undefined. And so we equate that, the C prime of W to 0. And so we get 0 equals 40W minus 240 over W squared. And then we solve that out, and we get 40W cubed over 40 equals 240 over 40. And we get value of W equals the cube root of 6. And so after that, we have to plug in this value into the original cost function. And so we get 20 times the cube root of 6 squared plus 240 over the cube root of 6. And we get a minimum cost of 198.12.
Okay.
And the reason we know why this is like the lowest value is because if you do the second derivative test, you get C double prime of W is greater than 0 for all values in the domain. So we know that W equals the cube root of 6 is the lowest.
Okay, so how do we find the critical point, critical number?
So the critical number is from the when you equate the C prime of W to 0.
Okay.
So when you do it's like F prime of X equals 0 basically.
Right.
But this case I put yeah.
Okay, yeah, very good. Okay, anyone has any questions? Okay, thank you.
Thank you.
Thank you. So that's Julie. Let's see the chat. Okay, anybody has any question? Okay, I think Henry is asking a question. How do you know when to use the squeeze theorem exactly? Well, for mathematics, sometimes it's trial and error, right? You see the inside the limit, you have x squared times sine 1 over x. Squeeze theorem is one of the strategy. Okay, I think Henry wants to try 12. Oh, Sophia, whenever you're ready, all right. Then Emily. Yeah, I see someone's work there. Let me see, let me minimize it. Oh, Henry, that's your 12.
Wait, can you hear me?
Yeah, now I can hear you.
And you guys can see the work too?
Yeah, can you minimize it? I only see part of it.
Oh wait, how do I minimize? I see the full thing.
Oh, I only see part of the. I only see part of it. Oh, I can. Oh, you are set. Right, minimize. Okay. No, still, I still only see part of it.
Wait, you still only see the part of it?
Yeah.
Okay. Maybe I'll fix it 1 second. Does someone want to go first so I can just re-upload it?
Sure. Let's see. Emily 25 was Sophia.
Good morning, Professor.
Good morning.
Okay, so u equals to 3x minus 5 and
Hold on. Remind us question.
1 second. I have it. Evaluate the following integral. Integral of cosine 3x minus 5 dx. So let u equal 3x minus 5 and the derivative of 3x minus 5 is 3. So du equals to 3 dx. So 1/3 over du equals to dx. In order to find du over dx, I did 3 divided by 1, which is 3. And then I rewrote the problem using u and du, which is our u is 3x minus 5 and du is 3 dx. And the integral of cosine u, 1/3 over du. And then since 1/3 is constant, I moved 1/3 out of the integral. So 1/3 the integral of cosine u du. the integral of cosine u is sine u. So 1/3 sine u plus c. And then I replaced u with 3x minus 5. So 1/3 sine 3x minus 5 plus c. And that's it really.
Okay, let me ask you some questions because something. All right, what kind of integral is this? So what kind of integral is this? We have two types of integral, right?
Yeah.
What type is that?
Let's see. Integral of cosine 3x minus dx. It's going to be, this is definite integral, right?
This is a definite integral?
No, I mean indefinite integral.
Right, indefinite integral.
Yes.
Wow. Right. It's the indefinite integral. Right.
Yeah. Yes, indefinite integral, correct.
Right. How do we separate, integral? How do we know one integral is indefinite? What definite? By what?
Second. I know the answer.
So what is the difference between definite integral and indefinite integral?
Indefinite integral, sorry, I'm just so nervous. I can't even think what that definite integral.
Well, don't be nervous. Let's think about this. Let's see if I have this.
Oh, because I'm reading from my notes if it's okay. A definite integral has upper and lower limits on the integrals, and indefinite integral is a more general form of integration and can be interpreted as antiderivative of the considered function.
Oh, we don't need to okay, that's a lot. But
yeah, I wrote in my notes like that.
Yeah, as you said, right?
Yeah.
Definite integral, we have a lower limit, we have upper limit. And indefinite integral, we do not have a lower limit, we do not have upper limit. So what in the result, right? Definite integral give us something as a result. And an indefinite integral gives something else as a result. You see, indefinite integral give us a family of functions. It depends on C, right? Depends on constant C. So what about definite integral? Definite integral give us, what does definite integral give us usually?
The area under the curve.
Area under curve or a number, right? Okay. All right. Okay, and my second question is this. I'm getting confused with this. Why you're trying to do du over dx equals 3 divided by 1 equals 3. I'm confused with this line. Because you use the u substitution. The second line, you said, okay, let me use the u substitution method. So let u be 3x minus 5. Then du equals to 3 dx. You already see the relationship between du and dx.
Yeah,
right?
I know. I just realized that now.
Right, then you said, okay, I want to switch the integral, I'll change to be cosine u. And also I need to change the dx in terms of du. So x equals 1/3 of du.
Yeah. So we already have that, so I don't need to do that.
Right, you don't need this totally, right? This is totally confusing, right?
Yeah. I get
Okay, all right. Thank you, Sophia.
Thank you.
Sophia. All right, anybody else? Oh, okay. So Henny, your work still the same thing. I only see part of it.
I don't know. I see the full thing, but I don't know why it's.
It's possible you, oh no, if you minimize, you still minimize this part of
Yeah,
it.
I see the whole
Oh.
thing too.
You can see the whole thing. Why I don't see the whole thing? So you're trying to, okay, can you screw up and down?
No, I can't.
Or you can't?
Wait, I can't minimize it anymore either.
Amir see, he doesn't.
What about
He doesn't
this?
see the whole thing. Because, okay, what I see is an equal sign.
Oh, that's it.
Right, I see equal, I see 2 equal sign. Oh, okay, hold on. 12 is in the middle, isn't it? 12 is
Yeah.
here. Let me circle it. Okay, you want to present this part. Oh, I got it. I got it. Okay. So I put a circle on it. Is that right?
Yeah.
Okay. All right. Now I got it. Okay. So your
For
12 is better. Your 12 is like embedded in the middle. It's very difficult to see this 12. But now I see it. Okay, go ahead.
For this question, they're asking you to find the derivative. So for here, I use the product rule and chain rule. So, and the product rule says you leave the first term and then find the derivative of the second term plus the derivative of the second term, and no, you leave the second term and find the derivative of the first term. So I got 3x to the fourth and cosine 1 over x, and then using the chain rule, so I take the derivative of the inside, which would be 1 over x squared. And then
Hold on a second. Let me ask you. What's the derivative of 1 over x?
1 over x squared.
Something's missing. Okay, keep going. Maybe when you explain the whole thing.
No, because 1 over x squared is also equal to x to the negative 1. So once you subtract 1, it will be x to the negative 2, and then you bring it back down. Does that make sense?
Okay, sine is cosine. Cosine of 1 over x, right?
Yeah.
So what's the derivative of 1 over x? 1
So
over x, right, okay, go ahead.
1 over x is equal to x to the negative 1. And then if you take the derivative of that, it would be negative x to the negative 2.
Okay,
I
so what is
forgot the
that?
negative sign.
That's right. Okay.
Can I add?
I'll add for you.
Okay.
I'll add for
Okay,
you.
thank you.
All right.
And then you leave the second term and then take the derivative of the first term, which would be 12 x to the third. And then I just clean it up a little bit, and you get negative 3x squared cosine 1 over x plus 12x to the third sine 1 over x.
Right. Okay, again, usually we write positive terms up front, right? You're missing negative sign, and then you're able to see your own mistake. All right, that's it. Okay. Thank you, Henry. Next, okay, let's see the chat. Anybody has any questions? Oh no.
Good morning, Professor. Can you see my work?
Good morning. Okay, so this is Emily.
Yes.
Yeah. So 25, right?
Yes.
Yeah.
Okay, so for number 25, I have to evaluate this definite integral from the lower bound 0 to the upper bound 5 for the integral of dx over radical 1 minus x. So first, I let u equal to 1 minus x. Du dx will equal to negative 1. And then solving for dx, it will equal to negative du. Then I will plug that into the original equation, which I will get negative integral of 0 to 5 for u to the 1/2 negative 1/2 du. And then I will take the antiderivative of that, which will equal to negative u to the 1/2 power over 1/2. And that will equal to negative 2 radical u. Then I plug in what I originally substituted, which will be negative 2 radical 1 minus x. And then I will plug in the upper bound and lower bound, in this case, which will be negative 2 radical 1 minus 5, which will give me negative 4 I, which represents the imaginary number, since it's a negative number within the radical. And then I'll subtract that from negative 2 radical 1 minus 0, which will give me the answer negative 2. Then I just rearrange it and I'll get 2 minus 4i.
That's it. Great. Okay, thank you. Thank you. This is Emily.
Yes, thank you.
Okay, do we have anybody else? Okay, I think that's it, right? Everybody claim has presented. Okay, anyone has any questions with the review sheet or with anything?
Professor,
Yeah.
I don't know if someone presented 18, but I was kind of confused about that one. So can we
18.
go over it? Yes.
Let's see. Yeah, Amir is asking what we will do. Well, let's talk about 18 first. Then I'll answer your question, Amir. So 18 is saying a cone has a radius of 18 feet and a height 54 feet. It's empty and it's being filled with water at a constant rate of this much. Find the rate of change of the radius of the surface of the water when the radius of the surface of the water is 7 feet. Okay. Because I don't want to talk about it. Because once I talk about, you will lose one question to get credit from. But go back to your homework. Go back to the recording. We talked about this a couple of times, and the question is exactly the same, except the number is being changed. All right. So it's time to study. It's time to study. Go back to study. All right, now this is okay. I can give you a little more hint. So the hint is this is a related rates question. Related rates. Related rates. I can talk a little bit. So related rates, right? So the volume is given. The volume equals to 4/3 pi r cubed. Right? Times h. Forgot the height. H. Right? So the volume of a sphere equals to 4/3 pi r cubed h. What's the picture? The picture is this. Think about an ice cream cone. Right? The typical ice cream cone. Like this. So what is the volume of this cone? So this is R. And h is from here, the measurement from here to here. This is the h. Oh, I'm sorry. what I'm talking about. That's right. Right. That's no 4. Thank you, Amir. Thank you, Amir. So the picture, this picture is right, but this volume is wrong. Those volume is wrong. The volume of a cone equals to 1/3 of pi times r square h, right? Am I right? Square right. Right. Okay. So the volume of this is 1/3 of pi, right? Pi is a number, 1/3 is a number. So r square h. So this r square h. All right. So we want to find change of one thing, affects change of the other. So how many variables do we have in total? We have 3 variables. So what do we want to do? We want to use related rates. Remember related rates? We'll do v prime. So we'll take a derivative of each. We'll take a derivative of it. Think about v prime as we have a one variable, invisible variable. So related rates involves one invisible variable, which is time. So you could think as dv over dt. Well, simply I like to use v prime, but in my head I know that's a change of v in terms of time. So dv dt equals to 1/3. Let's leave 1/3 of pi outside. Now I have 2 variables, right? So 2 variables, we need to use product rule. So we take implicit. So this is the implicit differentiation plus related rates. So we take a derivative with r, the 2r, then dr dt, then times h plus r square times dh dt. Okay, we could write this way. So I have a changing of v, right, equals to 1/3 of pi times changing of r. Right, we have r square, which is 2r times changing in r times h, product rule, right? Then plus r squared. This is r raised by 2. It's not and. R raised by 2 times changing in h, dh dt. Normally, I like to use the notation of v prime. So v prime equals 1/3 of pi times 2r r prime h plus r square times h prime. I like to use this notation, right? Then you should plug in the knowns, right? Then solve for the unknown. But the knowns, sometimes you need to do extra. You need to extra to find it. Sometimes one variable may appear to be unknown, but maybe through some other variables, you can find its value. So it's, hide and seek. So you try to find. So here you see the original volume equation. We have 3 variables. We have v, the volume, we have r, the radius, we have h, the height. After we differentiate, it involves the related rates, the speed of changing in each variable. So I have 6 variables. Solve for one variable. We need to know the other 5, right? Okay. Anyway, so that's my hint. Now let's talk about Amir's question. Amir is saying, we have so much time. We still have time left. What do we do with this? We still have questions not presented, right? Let me see. And most of questions, especially most of the easy questions, are being presented so far. But we still have so many students not presenting anything, not getting presentation grades. And also the homework, I checked your homework, the online homework. Strangely, some of you haven't done anything, but some of you have done everything. And some of you, halfly done. And some of you have done wonderful job so far. So what I need from you, what we need to do is to finish presenting this review sheet. All right, review sheet. Some of the questions have been presented already, but we're still left with many questions not being presented yet. So hopefully we can present all of those questions, especially this graphing. No one so far has tried to present 30, 31, 32 yet. That's a big part of this class. So I need people to show those. And also the integration. Integration, some difficult questions hasn't been presented yet. Yeah, Alexandra tried 43, which is very brave. All right. So hopefully by next class, we can finish presenting those questions. Once those review sheet questions are finished, I don't know, Amir, you have a very good question. So do you have any suggestions? Yeah, we still have some time, right? We have this Thursday is a Thanksgiving Day. We won't have class, so we will not meet on this Thursday. But then next Monday is 30. Then Thursday is 3. So we still have two classes before the final. So ideally, I hope we can finish presenting the review sheet so you can earn presentation credits. Let's see. Okay. I'm saying, isn't that in 2 weeks? Yes, we're finishing in 2 weeks. Noella, we can do more questions and problems for homework to get more practice. Noella, we can do more questions and problems. Well, for now, please focus on this review sheet. Right? Review sheet basically covered almost all homework. The idea, right? The type of questions trying to cover all the important material. Hinton, are we going to have appointment for our presentation part of the test? Let's see. What about the lumen problem? Yes, lumen problem, that's what I was talking about. Hinton, to answer your question, right? Again, we have so we have we have two more classes. So 2 more classes, I'm hoping we can finish presenting the review sheet. All right. Even you're not sure, you try, and I will help you. I will help you to get credits. Like Alexandra, right? Today, she tried a very hard problem to apply the fundamental theorem of calculus. Even she didn't do everything right, but because she's brave enough, and I still give her full credit for that. Because she understands the most part of it, and some part of it is difficult to explain. It's difficult to explain, but I will help you with that. Let's see. Amir is saying, what about right for Lumen problem? I don't want to show you because let me just see. Let me just give it. So I have one student. So let me see how many students finished everything. So 1, 2. No, this one didn't finish. You know, the platform has some bugs in it. So let me just see. So far, I just have one student. I just have one student finished everything. Let's see. Oh no, I have 2. I have Alexandra. Alexandra finished everything. Let me see who's this. I have Karen finished everything. Yeah, only those 2 students. Oh, hold on a second. Oh, one more. I have Ray Yang finished everything. Yeah, the platform shows me only those 3 students finished everything. Then let's see. I have here who's Mokira. Mokira never showed any presentation, but missing only last quiz, last chapter. Quiz from last chapter. Then let's see. Sophia missing the last one. George missed 2, but George never present. If you never present to me, right, it's hard. Even you do everything right, I guarantee you, you won't get A. All right. So you need to show me you understand that. Because if you only do the homework, you do the quiz or the exam, well, later on I give you a final exam. If you did everything right, who knows who did right? You have to show me. So you have to show me. You have to present. Oh, Vaughn is missing quiz 3. Carlos is missing the last quiz, the last chapter. Healing is missing the last chapter. Kaiser is missing the last chapter. Karen finished everything. Stanley, you didn't do homework? You didn't finish the homework? Stanley did all the quizzes, but on the homework side shows 0. Zuli is missing the last one, the second one, the second chapter, and the 4th chapter quiz. Angel, the last 2 chapters, 3 and 4. Jason, the last 2 chapters. Emily, the last 2 chapters. Alessandra finished everything. This is a Michael. The homework part is 0, but the quizzes are good. Malika is good on the, Malika is missing 3. But some of you missing 3, some of you haven't done anything yet. Okay, anyway, anybody else has any questions?
I'm sorry, this is Carlos. I have a question.
Yeah, Carlos, go ahead.
Yeah, in one of my quizzes, I had an N grade, N/A.
So Carlos, let me check for you. Carlos.
Quiz 2.
Quiz 2. No, Carlos, you are only missing the last one, chapter 4.
Yeah, because I wasn't
Chap-
sure if you went through, because I lost some sort of connection at the same time. And after that, it just came NA.
Oh, I have quiz 1, I have quiz 2, I have quiz 3. Yeah, I'm only missing quiz 4. I have homework. So on my side, I don't see your quiz 4 yet. That's it.
Yeah, I haven't done it yet, but I will.
Okay, all right. Everything else, I have it.
Okay, thank you.
You're welcome. Angel has a quiz 2. Let's see, Angel quiz 2. Angel, I have your quiz 2. I just don't have quiz 3, quiz 4. Okay, please, focus on those review sheet. Oh, let's see homework. Oh, homework, right? Homework, if you haven't finished, right, you need to finish the online homework. So for the final, did we see anything about the final? So 250, the final for 250 is going to be on the 7th. For this class, I think it's on 17th. I need to check the date. Maybe we can do earlier. So the final the time is limited. So final, I will post the final on, probably like the class time. Let's say, we start our class at 7, right? So I post the final on Blackboard, 7 o'clock. Then in 2 hours, so you have to return back to me. You have to submit your final in 2 hours. It's like by 9 o'clock. So you can send to my email. So by now, okay, what I'm thinking, what's in my head is I'm trying to still give you more opportunity to present, so you can get a better grade. Okay, let's see, anyone has any questions? Kini, I received everything, but not your homework grades needs to bump up a little bit. Because for homework, right? Homework, if your grade is 75 above, is you won't be punished for it. If it's a 75 below, it's below 75, make it better. Make sure your homework grade is above 75, so you can get full credit. And here, you're only missing the last chapter 4 quiz. And also your homework grade is about 65. or 66. So bump up the grade. Let's see, Noella is asking, will the final include one lengthy question or multiple shorter questions? I don't know. What do you prefer, Noella? Me saying, what is the way the final will be graded? Participation, what percent, and the actual questions on the test added to make a full score? Well, let's review our, what do you call it? Our, what do you call it? Syllabus, right? Let's go to our syllabus. Okay, the syllabus is saying 10% presentation, right? And then 20% homework, 30% quizzes, and 40% final. Okay, so this is 40% final. Oops. Okay, Noella is, let's see, let me see. Ray is saying for the final, is it computer grading? Because I noticed that sometimes I got the right answer, but the format is different that the computer mark is wrong. You know, I'm still thinking about this final, because I know a lot of you working really hard. I think, okay, professors, you said that you would increase the presentation percentage to a higher number. And just seeing how many questions will be on the final. Is it all written? Okay, anyone has any suggestions? Okay, I can bump up the presentation grade. That's no problem. But 10% is let's see. Let me see. So 10% presentation, 20% homework, 30% quizzes, 40% final. um, Okay, Rudy is saying she's thinking it would be better if I decrease the percent of the final and increase presentation percentage, since we will also be presenting for the final. You know what? It's a difficult time, isn't it? Let me check your. Let me think about all this. Okay, let me think about all this. Let me think about all this to see. To see what's the best way to give a fair grade to everyone. All right. So would you please keep working on the review sheet? Okay, I'd really like to see to finish presenting the review sheet. All right. Because okay, please you work on that. You work on finish the homework, finish the quizzes, the online ones, and also finish this review sheet problems. All right, and I will work on how to give the final and how to give a fair grade to everyone. All right. Okay, so let's do that, and let's do that, and have a happy Thanksgiving. All right, Thanksgiving. Oh, so sad. So sad. I'm going to spend Thanksgiving all by myself this year. And I'll see you next Monday, all right? No class Thursday. Thursday is a Thanksgiving day. No class. So happy Thanksgiving, all right? So you work on your part. I work on my part, all right? I need to make sure to give everyone fair grade. Okay, have a good day. Have a good week. Happy Thanksgiving. Yeah, happy Thanksgiving.